Welcome everyone. In this video lecture, we will solve a GATE 2025 easy question in which we have to find the current flowing through the resistor, capacitor and inductor. So the question is, let IC, IL and IR be the current flowing through the capacitor, inductor and resistor respectively in the circuit given below. So this one is the circuit in which capacitor, inductor and a resistor are connected in parallel with a voltage source, AC voltage source. Okay, and the current flowing is IC, IL, IR. And the given thing is the AC admittance are given. The admittance term are given, not the impedance. Okay, admittance, just the reciprocal of impedance are given in Siemens. Okay, S. Which one of the following is true? Okay, so the admittance term is given. So how to solve this problem? Okay, so first means first if we are considering the resistor here, suppose I am just making this resistor. Okay, and this resistor is given, I am saying this as a resistance R, and the corresponding admittance we can say, or a conductance can be written as G. Okay, just the reciprocal of this one. So here the conductance value of that particular resistance is given 0.2 Siemens. Okay, so G value is given 0.2 Siemens. Okay, so here what we are observing that this one for the resistor. Okay, so I'm writing here, this one is for resistor. Okay, now again for the, suppose capacitor first. Okay, capacitor, this value is J 0.25 S. Okay, this one is our capacitor. We will go with the basic. So this one is the capacitor. So this value is nothing but simply we can write as 0 plus J 0.25 S. Real part is 0, imaginary part 0.25, and it is in Siemens. Okay, so S is there, we can, or just it is in the Siemens. So Siemens unit is there. Okay, so here it is also in the, this one is the Cartesian format. Okay, and for the inductor, for the inductor, okay, this one is our inductor. For inductor it is given minus J 0.1 S Siemens. Okay, so I can also write minus 0 minus J 0.1 times of S. Okay, so this one, and one more thing that I want to write here. This, I am saying this one is a capacitor having conductance. So I am just denoting with Cg, and this one is Lg. Okay, means in terms of conductance value is given. Okay, means this one is our Cg. Okay, Lg. I am saying this as a, you can say Cg. This as a Lg, and this one is a G, or you can write it Rg, anything. Okay, or so you can write it Rg. Okay, Rg. Okay, I'm just copying this diagram. Okay, so we have to, okay, control C is there. Copy, paste. Okay, clear. The same figure I want copy. Okay, we are getting some issue, so we will make this one. Okay, this one is the figure. So this one saying CG, everything is now known to us. So but here the voltage source, now the voltage source having voltage in the polar form 190-degree volt. Okay, it is in the polar form. So it will better to convert all the admittance in the polar form. Okay, so first we have to start with the resistor. For the resistor part, for the resistors, Rg is already given. I am saying Rg, it is 0.2 Siemens. Okay, 0.2 S means Siemens. So as we know the formula V equals to IR. Okay, so this V and I instead of R, I am writing 1 by Rg in terms of conductance. Okay, Rg, I am saying this as a conductance. Okay, conductance or admittance term. Okay, so the value of I is nothing but simply V into Rg. We have to find the current I. Okay, so here what we can write, ISR is nothing but simply the voltage, this voltage. Okay, I am saying this as a voltage V. So V times of what, Rg. Okay, so here what we observe that this one is a resistor. So resistor having only real part, no imaginary part. Okay, so real part. So this Rg value that I want to write here, Rg value is 0.2 plus j0, j into 0. Okay, I am just showing j into 0. Then if you write in terms of its corresponding polar form, what we have to write, suppose for the theory purpose, a plus ib is some function, impedance function. If we have to write into corresponding polar form, so A can be written as r cos theta and B can be written as r sin theta. So the Z value will be r with angle theta. Is it okay? This one is our corresponding, where r equals to a square root of a square plus b square and theta is equals to tan inverse b by a. This one is our some theory. This one is our theory. But for the resistance part, Rg is 0.2, angle is 0. Okay, so the value of Rg can be written as simply 0.2 with angle 0. Is it okay? Because R, here this value 0.2, or you can write as 0.2 equals to, for example I am writing r cos theta and 0 is r sin theta. Okay, then this say equation 1 and equation 2. Then what I am doing, 1 square plus 2 square. Okay, adding both. So what we can write, 0.2 whole square, I am just showing r square cos square theta plus r square sin square theta. So this value will be r square into, okay, I am writing each and every step. So this one is r. So r value will be 0.2 and theta will be tan inverse b by a, or if we divide 2 by 1. Okay, if we divide 2 by 1, so what we will get, 2 divided by 1. So r sin theta by r cos theta, 0 by 0.2. Okay, so it is simply 0 tan theta 0, or simply from this r we know, r value we know, na, r value is 0.2. So one more equation we can add, 0.2 equals to 0.2 cos theta. Cos theta is 1. So cos theta value 1 at theta equals to 0 degree. Theta equals to 0 degree. So this value will be what, Rg 0.2. So this is very simple, but the process that we have to know, 0.2 in Siemens is there. So what we can write, it should be 0.2 angle 0 degree. So now we can find the current. So the IR value is equal to V. So V is given 1 angle 90 degree. Okay, so write it into RG. RG value is now 0.2 angle 0 degree. So these two will be multiplied and the angle part will be added. So angle part will be added 90 degree plus 0 degree. So it should be 0.2 first part IR. Now IR means IR equals to VRG. I am writing RG. Okay, because this RG is our admittance. Okay, so these are the means process to how to convert the Cartesian to polar form. So because the voltage is in the polar form, voltage is given polar form in polar form and the RG. So just IR. Okay. So now this current we know now 0.2 angle 90 degree. Okay. 0.2 angle 90 degree. Now we have to do it for suppose inductor. Inductor. I am solving with full basics. Okay. For inductor. So this one is the inductor and the admittance value is given minus 0. Minus j 0.1 s is given. Okay, so I am saying the admittance term is this lg value we can write as lg value can be written as 0 minus j 0.1 in siemens. Okay, so now because voltage in the polar form, so convert it to its corresponding polar form because this one is voltage in the polar form. Okay, and what we have to do, we have to just multiply the conductance or admittance term with the voltage. So we have to convert all the admittance in the corresponding polar form. So this one, so how we do for this one again. So what we can write, 0 equals to r cos theta and minus 0.1 equals to r sin theta. Okay, we are just converting real part r cos theta. I am writing this as a r cos theta plus j sin theta first. Okay, into s. Then okay. So now from here, what we can write, r square, because this one is r square cos square theta plus r square sin square theta equals to 0.1 whole square. We can write because say I am again saying 1 and 2. What we are doing, 1 square plus 2 square. Okay, and adding these two equations. Okay, so simply we can write 0.1, so r value will be 0.1. Okay, now angle we have to write. So r cos theta equals to 0, so cos theta is r is 0.1, so r cos theta equals to 0, r is 0.1, so cos theta is 0, so theta will be 90 degree. Theta will be 90 degree of pi by 2. Here, see, this one is a cos, na? Cos diagram. Cos, okay. So, this should be our y equals to say cos theta, and this one is theta. So, at what point it is 0? So, it is a 0, yes or no? So, angle means for the inductor one means r cos theta equals to 0. Okay, so r cos theta equals to 0, so cos theta is 0, so 0 at pi by 2. So one point is this. Okay, one more thing, here r sin theta equals to minus 0.1, r sin theta equals to minus 0.1, and r value is how much? R value 0.1, and 0.1 sin theta equals to minus 0.1. So sin theta equals to minus 1. So here two different things. Sin theta equals to minus 1 is also coming. Okay. So what we will do? R sin theta equals to minus 1. So if you plot sin theta, okay, so minus 1 at minus pi by 2. This value minus 1 at minus pi by 2. So angle will be minus 90 degree, and here the angle will be 90 degree. So but for the inductor it should be minus 90 degree. Okay, so this angle will be minus 90 degree, because in the inductor it should be the phase should be minus 90 degree. Okay, so the IL value will be simply 1 angle 90. Okay, voltage into the corresponding admittance 0.1 into minus 90 degree. So it should be simply 0.1 angle 0 degree. Simply we are just IL, we are putting the voltage source into the LG. Okay, so we have to consider this one, this phase r sin theta equals to minus 0.1. Okay, clear this one. So now for the, now we have to do it for the what, capacitor. Okay, now for the capacitor, the value is given j 0.25 s, means the cg, the admittance is given, can be considered j 0.25 s. Okay, in Siemens. Okay, so again 0 you have to consider as a cos theta or r cos theta, better to write r cos theta. 0.25 is r sin theta. So R value will be 0.25, okay, by squaring both equation and adding, okay, and theta will be what, R sin theta is 0.25, R sin theta 0.25, so sin theta equals to 1, so theta equals to 90 degree. Yes or no? R sin theta, so theta equals to simply sin theta equals to 1. Okay, means this should be 0.25, R value is 0.25, sin theta. So sin theta equals to 1. So theta equals to 90 degree. So the I of C will be voltage into C admittance. So voltage is the 1 angle 90 degree into CG. CG will be, this can be written as 0.25 angle 90 degree. So 0.25 angle 90 degree. So it should be 0.25 angle, the angle will be added 180 degree. So the value will be, the IC value will be 0.25 angle 180 degree. Okay, so clear this one. Okay, so the final answer will be for the IR 0.2 angle 90 degree. I am writing here first. IR value will be 0.2 angle 90 degree current, this IR value. Okay, IL value we have calculated, IL 0.1 angle 0, 0.1 angle 0 current, this IL current 0.1 angle 0, and now this one 0.25 angle 180 degree, and all in ampere, we can say ampere current. So which one is the correct answer for IC? 0.25 180 90 degree, IL 0.1 0, IL 0.1 with angle 0, and IR 0.2 with angle 90 degree. So the option number 1 will be the correct one. Okay, so this one is easy, but we have to careful about this admittance term, and we are writing like this: current, and current is voltage into conductance. This one is our conductance, or better to say admittance. Admittance. Okay. Then for the angle calculation, take, okay, for here the for the angle calculation, You have to just select the r sin theta equals to minus 1. Okay, r cos theta, if you write, it will give the 90 degree, but for the inductor phase one will be minus 90. So like that you can do for the capacitor. It is 90 degree, 180 degree will 90 degree will come. So this is all about this question. This is a question from the GATE 2025 EC question. So thank you for watching this video. Thank you.